everyone! In this video, we're going to do the KutaSoftware Infinite PreAlgebra free worksheet one-step equations with decimals. Very similar to one-step equations with integers, except now we're just working with decimals. So our directions for this worksheet are to solve each equation. And remember, by solving the equation, we're isolating the variable. In the case of number 1, that's p. So we're going to be isolating that variable, getting it all by itself, and that is going to give us our solution. So taking a look at number 1, again, we're isolating this p here. In order to do that, we need to move this 8. Since the 8 is added to the p, we're going to subtract it from both sides of our equation. Now this one is fairly simple. We'll be able to do this in our head. We know that a positive 8 minus 8 is going to give us 0. That's why I took that 8 away. Taking that 8 away, p plus 0 is just going to be p. So I'll write the 0 in this step, but in a few more steps I'll start dropping it. So don't be alarmed when you see that 0 disappear, because 0 plus anything is what you're adding it to. And then we have 14.1 minus 8. This one we can do in our heads. We know that 14 minus 8 is 6, so 14.1 minus 8 is going to be 6.1. So we get that p, since p plus 0 is p, equals 6.1. And what I like to do, I like to box my answer once I get that final solution. Sliding on over to number 2. In number 2, we have n as our variable, and we're adding 4.7 to n, and that's equal to a negative 4.7. Remember, we're isolating, aka getting n all by itself. So in order to get the variable all by itself, we need to remove this positive 4.7. In order to make it go away, we're going to subtract it. Because look what happens when we subtract it. We're going to have n still remaining, plus 4.7 minus 4.7 is 0. And we know that n plus 0 is going to be just n. But remember, what we do to the left-hand side, we must do to the right-hand side, and vice versa. Whatever we do to the right, we do to the left, because this is the equation, and we need everything the same on both sides. Negative 4.7 minus another 4.7, well, a negative minus a negative, we're going to combine those negatives and go further into the negatives. So I know that 7 and 7 make 14, or 7/10 and 7/10 make 1.4. And I know that negative 4 and negative 4 make a negative 8. So essentially, out of this, I have a negative 8, and I'm still taking away another 1.4. Negative 8 minus 1.4 is going to be negative 9.4. So I get that n plus 0, which is n, equals a negative 9.4. And let's go ahead and box our solution. Moving on to number 3, now we have x, our variable, divided by 1.2 equals negative 7. Remember, if we're dividing, in order to essentially cancel that out, we're going to be multiplying. So we're going to multiply by this 1.2. So let me quickly just cover up this 3 so we can't see it for now, just so it doesn't get in our way. We're going to have 1.2 times x over 1.2, and then whatever we do to the left, we do to the right. So we're going to multiply that negative 7 by 1.2 as well. Now when we multiply, notice that 1.2 divided by 1.2 is equal to a positive 1. So they cancel out in the sense that they're just equal to 1. And 1 times any number is that number we're multiplying by. So 1.2 over 1.2 is 1, and 1 times x is going to give us x. So we have x equals negative 7 times 1.2. And this one isn't too difficult yet, so let's just do it by hand, and later we'll use a calculator. So I'm just going to write this as a 1.2 times a positive 7, but a negative times a positive is going to be a negative, so I know my answer is ultimately negative. 2 times 7 is going to be 14, so I'll put my 4, carry over my 1. 1 times 7 is 7, but I've got to add that 1, and that's going to be 8. But 84 obviously doesn't make sense for this problem, and that's because I have to remember my decimal. My decimal is 1 place over, so I'm going to move it 1 place over. That's going to be a negative 8.4. So negative 8.4 is x for number 3. Moving on to number 4, we're going back to some addition. So we're adding to our variable. So in order to isolate in, we're going to need to subtract. So we're going to have minus 3.9 on my left-hand side, and I'm going to take that away on my right-hand side as well. 3.9 minus 3.9 is going to leave me with 0, and in plus 0 is just in. So we're going to get that in is equal to 0.7 minus the 3.9. Well, if we're taking away 3.9 from a positive, if we take away 0.7 from that 3.9, that's going to leave us with 3.2. And remember, that is overall going to be negative since our negative is larger. So in is equal to negative 3.2. Moving right along, we're going to go on to number 5. In number 5, we have a negative 6.3 multiplied by our variable n, and that's equal to a negative 8.19. In order to essentially cancel out the multiplication, we have to divide. Just as above, when we had division, we multiplied. Now that we have multiplication, we're going to divide. So we're going to divide by a negative 6.3 to both sides. Remember, whatever we do to the left-hand side of our equation, we're going to do to the right-hand side. Negative 6.3 divided by a negative 6.3 is going to leave us with a positive 1. So we're going to have 1 times n, which is 1n, or simply n. So n is going to equal negative 8.19 divided by negative 6.3. Now you can do this using some long division, but for the sake of time, I'm going to go ahead and pull up a calculator. The online calculator I like to use is called Desmos, and you can find that scientific calculator. It should be right up here in our right-hand corner of the screen now. So we're going to type in negative 8.19 divided by a negative 6.3, and that's going to give us a positive 1.3. Negative over negative is a positive. 8.19 divided by 6.3 is 1.3. So in our solution is 1.3. Our variable is 1.3. Let's move on to number 6. For number 6, we have 32.663 equals p plus 11.363. What are we going to do? Isolate that p. How do we isolate it? By getting rid of what it's added with. So in order to do that, we're going to subtract. We're subtracting 11.363 from both sides. And if I keep my decimal in line, we can just do the math. 3 minus 3 is 0, 6 minus 6 is 0, 6 minus 3 is 3. Keep that decimal in line. 2 minus 1 is 1, 3 minus 1 is 2. So 21.300 equals p. Remember, those cancel out because they go to 0, and adding 0 to p is just going to be our variable p. So we get that 21.3 is equal to p. So if we were to take this 21.3 and plug it in, right on in for that p, 21.3 plus that 11.363 is going to equal our left-hand side of our equation. We're essentially just solving for what's missing. Let's move on to number 7. In number 7, we have our variable and we're taking away from our variable. In order to cancel out the subtraction, we're going to do a little bit of addition. So we're going to be adding 25.4 to each side. And adding 25.4 to a negative 44.8, we're still going to be in the negatives. So we'll get that n is equal to, this might be easier to think of as 44.8 minus 25.4, because that's going to tell us how far into our negatives we wind up going. We're taking away a positive 25.4 from that 44.8. That's going to tell us how far we still are in our negatives. 8 minus 4 is 4. 4 minus 5, can't do that necessarily, so we'll cancel out this 4, drop it down to a 3. This will be 14. 14 minus 5 is 9. 3 minus 2 is 1. So that's going to be 19.4. And remember, overall it's negative. So that's a negative 19.4 for number 7. For number 8, we have 28.8, 28 and 8 tenths, and that's equal to 18 times x. In order to isolate x, we need to get rid of that 18. And how do we do that? We do it by dividing it. So dividing by 18 is going to leave us with 1 times x, which is essentially just x. And then remember, whatever we do to the right, we have to do to the left. So we're going to divide 28.8 by 18 as well. This one might be helpful to use a calculator, but you could do long division if you wanted to. So we're going to say 28.8, and then we're going to divide that by 18, and that's equal to 1.6. So 1.6 is our solution for number 8. Continuing on to number 9, we're back to subtracting from our variable. So if we have our variable x minus 18, what we're going to need to do is we're going to isolate it by adding 18 to both sides. And adding 18 to both sides, we'll have x just on the left-hand side, and that's going to be equal to, well, if we cover up this 6 for now, negative 36 plus 18 is going to be still a negative 18, because 18 plus 18 gives us 36, but if we're negative and adding to that negative number, we're moving to the right on our number line, so we're getting a little closer to 0. So we don't want to get further away from 0, we want to get closer to 0. So that's going to be a negative 18, but now let's look back at that 0.6. That'll leave us with a negative 18.6. So lots of times when dealing with negatives and positives, especially with decimals, I always think of a number line. We're starting at negative 36.6. We're adding 18 to it. Where are we going to end up on our number line? That's going to be what x is equal to. If we took away 18, we'd be going the wrong way. Let's move on to number 10. For number 10, we have m minus 21.1 equals negative 36.6. So get ready to just kind of visualize that number line in your head. In order to isolate our variable, we're going to have to add what is subtracted from it. So we're going to be adding 21.1 so that we can cancel it out. Whatever we do to the left, we do to the right. So we're going to have m on our left-hand side equal to negative 36.6 plus a 21.1. Think about that number line. We're going to be getting closer to 0. So starting at negative 36.6, we're going to be adding 21.1 to that number. So adding 21 to a negative 36, we're going to be at a negative 15. But remember, we still have to deal with those decimals. So we're going to do 36.6 minus 21.1, and that's going to give us our negative number. Again, one more time, just in case you're confused, the way I like to think about this is if we're starting in the negatives and we're adding, this number I know is going to get smaller. So I'm going to write it as a positive because I'm used to working with positives. That's how we start out with learning. And I'm going to subtract 21.1 from that because I know that this number here is going to get smaller in the sense of its distance from 0. Not smaller going more towards left, smaller in the sense that it's getting closer to 0. So 36.6 minus 21.1, that is our 15.5. But this is ultimately still negative because 21 is not greater than that 36, so we're not going to bump all the way into the positives. We're still hanging out in the negatives. So negative 15.5. Moving on to number 11, we are going to definitely use a calculator for this one. We have x divided by 19.7 equals this super long decimal. But don't worry about it. What do? In order to isolate x, we're going to multiply by what's in the denominator. So we're going to multiply everything by 19.7. 19.7 will cancel out because 19.7 divided by 19.7 is 1, and 1 times x is x. So there we go. We've isolated that x on one side of our equation. Now we just have to do the multiplication over here. Going back to that calculator that should still be in my upper right hand corner of my screen, I'm going to type in 0.609137055,838, multiply that by 19.7, and look at that, we get a nice whole number 12. So x is equal to 12. Again, what that means is if I plug 12 right on in for x, 12 divided by 19.7 is this super long messy decimal. That is what makes our equation true. Let's move on to number 12. In number 12, probably want to use the calculator again for this one. We have negative 10.91 multiplied by our variable, so in order to isolate that variable, we're going to divide by what it's multiplied by. So we're going to divide by negative 10.91, and we're going to do so on both sides. When we do that, on the right-hand side, we'll have 1 times k, which is just k, and on our left-hand side, typing that into our handy-dandy calculator, we're going to get negative 165.832 divided by a negative 10.91. Negative over negative is just a positive, and that's going to be positive 15.2. So 15.2 is going to be equal to k. Let's move on to number 13. So by now we should be getting really familiar with what we're going to do. Yeah, these decimals look really messy. They don't look fun to work with, but if you think about it, we're just going through simple steps. These are one-step equations. We're going to do one step to get our answer. A, we need to isolate it because it's our variable. We're dividing by some number. We don't want to do that. We're going to cancel it out. One step, we'll multiply everything by 15.9. So when I multiply everything by 15.9, in that one single step, I isolate my a. So my variable a is equal to whatever this math works out over here to be, which let's go ahead and do it on a calculator. Negative 1.79245283,019, multiply that by a positive 15.9, gives us a negative 28.5. There we go. That's our solution, negative 28.5. Sliding on over to number 14, the last problem on this page before we move on, we have n minus 14.7 equals 4.7. This is going to be a nice one that we won't need to use the calculator for. How we get rid of that minus 14.7, we're going to add 14.7 to both sides. And when we add 14.7 to both sides, on our left-hand side, we'll be left with just n, and on our right-hand side, 4.7 plus 14.7. This is why we need to be neat. Let's get this in line so that we can go ahead and use the US algorithm. Here's my 14.7. US algorithm, just a fancy way to describe how we're going to add this vertically. 7 plus 7 is going to be 1.4. So we're going to leave our 4, carry over our 1. 1 plus 4 plus 4 is going to give us 9. And then we still have a 1 over here. Keeping that decimal in line, we'll drop it right on down. N is equal to 19.4. And again, that US standard algorithm is just when you line everything up and you carry over your 1s. Same applies to subtraction, except as opposed to carrying over, then you're going to be borrowing. Let's go ahead and move on to our next page. Jumping on into number 15, again, one step, what are we going to do? Our variable, we're currently dividing by some number, so in order to get rid of it, we're going to multiply by it. When we multiply by that, you can see that it's going to cancel out because 4.2 divided by 4.2 just equals 1. So there we go, in one step, we've isolated our b, but remember, we multiplied by 4.2, so we're also going to have to multiply by 4.2 on the side as well. Let me just go ahead and cover up this 15, make it a little bit easier to see. So 4.2 times that decimal, let's go ahead and use our calculators. 4.2 times 0.357142,857,143. that's going to give us a positive 1.5. So 1.5 is equal to b for number 15. Let's move on to number 16. In number 16, as opposed to having our variable divided by some number, it's multiplied by some number. But in order to cancel it out, we're going to think about it. If it's multiplied, in order to cancel, we divide. If it was added, we'd subtract. If it was subtracted, we'd add. If it was divided, we'd multiply. So we're just doing those opposite operations. So dividing by a negative 5.2 is going to leave us with a positive 1, and 1 times x is x. So we're going to divide by a negative 5.2 on our left-hand side as well. Negative divided by a negative is going to give us a positive, so I'll go ahead and just type these numbers in as positives. So we get a 38.48, and we're dividing that by a 5.2. That gives us 7.4. So 7.4 is our solution for number 16. Moving on to number 17. Remember, if we're adding to a variable, in order to get rid of that, or in order to cancel out what's added to it, we're going to subtract. So we're going to subtract a 6.6. And we're going to do that from both sides. And notice, I've kept my numbers in line, so we can go ahead and use that US standard algorithm when subtracting. 6.6 minus 6.6 is 0, v plus 0 is v, and that's going to be equal to 1 minus 6. We can't do that, so we're going to have to borrow. Canceling out this 2, I'll borrow from that and leave it with a 1, and then I'll put an 11 as opposed to a 1. 11 minus 6 is going to give me 5. 1 minus 6, again, can't do that, so we can cancel out this 3, turn it into a 2. That 1 then would become an 11. We're taking from that place and putting it into our next one over. So 11 minus 6, again, is 5, and then we have 2 minus, well, nothing's down there, so 2. That decimal kept it in line. That is a 25.5. So 25.5 is our solution in number 17. And if you need help with the US standard algorithm, I'll go ahead and make a video on that. But for now, just remember to keep everything in line, and then feel free to double check with the calculator. Moving on to number 18, again, looks a little scary, big messy decimal, but remember, this is just one step. P is divided by 9.5. We want to isolate that P. Isolate it means just to get it all by itself. So we're going to just multiply by 9.5. So when we multiply by 9.5 on the left-hand side, we have to do so on the right-hand side. So we have 9.5 divided by 9.5 is 1. 1 times P is P. Or even P divided by 1 is P. Doesn't matter where that 1 goes. Dividing or multiplying by 1 is just going to give us what we're multiplying. Then, again, let's go ahead and type this into our calculators. So we get 2.78947368.421. Multiply that by 9.5 is going to give us a fairly nice decimal, 26.5. So 26.5 is our solution for number 18. Keep on moving on. Let's go to number 19 now. In number 19, we have a negative 14.896 equals r plus 11.704. In order to cancel out some addition, what are we going to do? We're going to subtract. So we'll subtract 11.704. And again, let's go ahead and keep this in line so we don't have to worry about using a calculator. On my right-hand side, that's just going to be r. And on my left-hand side, think about it. I have a negative number, and I'm going even further into the negatives. So I want this number ultimately in the end to get larger in the sense of its distance from 0. So I want 14 to be even larger. So just even estimating, looking at a negative 14 and taking away 11 more, that's going to be probably around a negative 25. Because 4 plus 1 is 5, and 1 plus 1 is 2. Negative 14 minus 11 is going to be a negative 25. But let's involve the decimals now, and again, I'm going to do this by essentially adding these together. So 6 plus 4 is going to be 10. So 0, carry my 1. 1 plus 9 again is 10. 0, carry my 1. 8 plus 7 is 15. Plus 1 is 16. Carry my 1. And then I'll go ahead and put my decimal now just to keep it in line. 1 plus 4 plus 1 is 6. 1 plus 1 is 2. So we're a little off from our original guess of 25, but that's okay. And that all came from carrying stuff over. And remember, we had a negative and we were subtracting a positive, which subtracting a positive is the same as adding a negative. Negative going further into the negatives, we get negative 26.6. So negative 26.6 is equal to R. Moving on to number 20. We have 21.7 equals M minus 7.7. How do we cancel out a number that's subtracted? We're going to add it. So we're going to add 7.7 to both sides. And let's make sure to keep those in line so we don't even have to worry about going to our calculator. We're going to get M on our right-hand side is equal to 7 plus 7 is 14. So that's going to be a 4. Carry over the 1. Keep that decimal in line. So I'm going to just drop it on down. 1 plus 1 plus 7 is 9, and then 2 plus essentially 0 is 2. So 29.4 is equal to M. Let's move on to number 21. Again, super messy, really long decimal, but like all these others, it's just one step. N is divided by something, so we're going to multiply by what it's divided by. That's in order to cancel it out, to leave us with just N, and whatever I do to the left-hand side, I have to do to my right-hand side. So this also gets multiplied by 16.4. Doing this on our calculator, definitely don't really want to do that one longhand. 16.4 times negative, well, we know ultimately our answer is going to be negative. So if you want to write negative now, feel free to, but I'll just finish this out. Negative 1.55487804878. Negative 25.5 for number 21. Moving on to 22. N plus 15.64 equals a negative 13.26. So we're going to get rid of this 15.64 by subtracting by 15.64. Now remember, we're going further into those negatives, so I'm just going to treat this like addition over here. A negative minus a positive is a negative plus a negative. So that negative number, we're getting further from 0. So this is going to be N equals 6 plus 4 is 10, carry the 1. 1 plus 2 plus 6 is 9. 3 plus 5 is 8. 1 plus 1 is 2, and that's going to be a negative 28.90 or negative 28.9. Feel free to just drop this 0 off because there's nothing to the right of it. So negative 28.9 is equivalent to negative 28.90. So just go ahead and drop that 0 off. Moving on to number 23, 8.8 equals M minus 13.4. What are we going to do? Add the 13.4 in order to cancel it out. And when we add it to both sides. Keeping everything in line, we're going to have 8 plus 4, which is 12, so that's going to be 2. Keep that decimal lined up, carry my 1. 1 plus 8 plus 3 is going to be 12, so 2. Carry on over my 1. 1 plus 1 is 2. So 22.2 is equal to M. And number 24, V plus 4.4 is equal to that 26.6. So in order to isolate V, we're going to subtract 4.4. So subtracting 4.4, a positive minus a positive, so we're just going to do this as is. 6 minus 4 is 2. Keep that decimal in line. 6 minus 4 is 2. 2 minus 0 is 2. 22.2 is equal to V. So, same exact answer we just got in number 23 for number 24. Moving on to number 25, we have something multiplied by x equals something else. We want to isolate that x, so we're going to divide by what it's multiplied by. So divide by 89.7. That'll leave x on our left-hand side equal to, let's go to our calculators, negative 2,296 and 32 hundredths divided by a positive 89 and 7 tenths. Negative divided by a positive is going to be a negative, and that's a negative 25 and 6 tenths. Moving right along to number 26. Again, let's use our calculator for this. Our variable is multiplied by some number, so in order to isolate it, we're going to divide by that number. So dividing by negative 73.8, negative over negative is a positive, so I'm going to get that r is equal to some positive number. Let's see what positive number that is. So I'm going to have a negative 5,704.74 divided by a negative 73.8 is going to be 77.3. So 77 and 3 tenths is our solution for number 26. Now moving on to our last two problems on this worksheet, we'll go ahead and do number 27. 27, we have some variable divided by a number. In order to cancel it out so that we can isolate the variable, we're going to be multiplying by that 41.6. So if I multiply by 41.6, I have to do so on my right-hand side as well. So multiplying by 41.6. So x is equal to, let's go over to our calculators, negative 2.3413461538 times 41.6. That's a negative 97.4. So negative 97.4 is our solution in number 27. Now, our last problem, number 28. And before you go ahead and dive into this, if you haven't already, feel free to like this video and subscribe to my channel. All likes and subscriptions are greatly appreciated. So, let's just finish this out. If we're subtracting some number from our variable in order to cancel it out, in one step, we're going to add. So 43.4, adding it to the left-hand side will leave us with b minus 0, or b plus 0, which is just b, and we're going to also add it to our left-hand side. So adding our 43.4. Now remember, a negative, if we're adding a positive, thinking about that on our number line, we're going closer to 0. So we want this number to be closer to 0 on our number line. So the distance from 0 is going to get smaller. It's still going to be negative, but it's not going to be quite such a large valued negative. So let's go ahead and do this one on our piece of paper as opposed to using a calculator. So I'm going to have 120. I'm going to write it as a positive, and I'm going to subtract the 43.4. So I'm just going to flip my signs, making this a positive and subtracting this. And that's going to tell me where I'm going to land at in my negatives. I know this number is negative because 43.4 is not a larger distance than 120 is. But in order to subtract 43.4, I'm going to have to put a placeholder decimal. Can't subtract 4 from 0, can't subtract 3 from 0, so I'm going to go ahead and borrow from this 2. So I'm going to make the 2 a 1. This becomes a 10, but I'm borrowing from this, so make that a 9. And now I finally have a 10 over here, which 10 minus 4 is 6, 9 minus 3 is 6, and then 1 minus 4, I can't do that. But look at this, if I borrow, I'm going to wind up with 11. So 11 minus 4 is going to be 7. So this is 76.6, and remember, that is a negative 76.6. So negative 76.6 is our solution in number 28. Now, if any of this adding versus subtracting confused you at all, just remember that whenever you add a negative, it's the same as subtracting a positive. So if you're starting with a negative and you're adding a positive to it, you're getting closer to 0 or potentially surpassing 0. And I have more detailed videos on how to do this if you were ever confused. So just leave a comment below and I'll link you to that video. And again, this is a free worksheet from the KutaSoftware website. I'll leave a link in the description below. And as always, don't forget to like, subscribe, and share.